In this video, we're going to review some of the basics around nth roots and rational exponents. When we talk about roots and exponents, we also have to mention radicals because that's the visual way that we represent those things. So to remind you, a radical is anything that looks like this. It's like that long division symbol, but it has this little thing over here. And there's a lot of different properties here. So we know that there are exponent properties, so there's also radical or root properties. So there's the multiplication, saying that if I multiply two things under the same root or radical, I can split them up, and they operate the same way. And then working backwards, division, same thing. It's like if I have a fraction under one radical, I can break that up into two as long as they have the same root right here. And then the powers, this is an interesting one. So if I put the n, where you have the n, and then the m underneath the radical, it's the same as writing it the same way with the n here, but then putting the m on the outside of the whole thing, that actually gives you the same result. And when we have square roots or cube roots, that's when we have things to the 1/2 or the 1/3 power. And then if you have something underneath the radical here, that just becomes the number all over 2. And you can look at that example here. Another thing that's pretty self-explanatory is that if I have a radical here with x underneath and a up here, and that equals y, I can also flip those around and bring y to that exponent will give me x all by itself. Another thing that I want to mention is that it's really easy to get caught up in when you're speaking to just say radical this, radical that, but you do have to specify the root. So oftentimes we'll say the square root or the cube root or the fourth root or something like that. So a radical is a more vague notion of what a root is. So let's start working with some of these radicals. So something I didn't mention yet is that when you have a radical or a root and you don't have a number here, like what you have a 3 here and a 3 here, if you don't have a number there that is supposed to be a 2, or that's a square root, because square roots are pretty common, they kind of just drop the 2 on it. You can include it if you want to, but it's not necessary. So something that may be worth it for you to memorize or to have a list of somewhere are all perfect squares, 1 through 15, and then also perfect cubes, 1 through 15. The more you work with them, the easier it is to memorize them. So something that I do with this is I break this up into radicals that are perfect and then whatever's left over. So 16 times 2 is 32, and the square root of 16 is 4, so that's 4 square root of 2. And then here I have a cube root of 16. Now I know a perfect cube is 8, and then what's left over is 2. That becomes 2 cube root radical 2. Another little mini thing to keep in mind is that if you've got a number out here and something on your root, I would either put a little bit of space or make sure that you know that that one's bigger than this one, because sometimes when you write it or when you read it, it may look different than what you meant it to be. So just be very specific when you're writing certain things. And then what I have over here is I have a negative cube root of negative 16x to the 4th. So I'm going to break that into these two things. Now, I can have a negative under a cube root, but whenever I have a even root, like over here, if I had a negative, that doesn't exist in the rational number plane. We'll get to that later. But here I can have a cube root that's negative, because if I had like -1 times -1 times -1, that's -1, and that's totally fine. So I'm going to actually break this up again. And what I've done is I've taken the negative and put it over here, put the 2 here, and then I broke up this x to the 4th in x to the 3rd, because that's going to cancel the radical and that root, that exponent there, and then I'm left with the x to the 1st. So let's simplify that further. And I'm going to combine the negative 2 and the x to make it negative 2x, cube root of 2x. And I'm going to take that a step further and I'm going to combine like terms. So this is like working with a polynomial, same rules apply when I work with radicals. What I'm going to do is I'm going to simplify each of these terms and combine what I can. So here I have broken up each of these terms, and what I notice is I've got this in all three of them. So I'm going to take this out and then simplify the rest of it to combine all my like terms. So in the end, what I've done is I've taken all these out. I kept my 2x minus 1 plus 12. I simplified that to 2x plus 11, in parentheses, all multiplied by the cube root of x. Something else that's ridiculously helpful here is a process called rationalizing the denominator. So that's exactly what it sounds like. We're looking to have only rational numbers in the denominator. Radicals, cube roots, square roots, any type of root is not a rational number. And although it's okay in math to have a radical in the denominator, for our intents and purposes, it just doesn't suit what we want to do. So we prefer to have a rational number in the denominator. And it's painfully easy to get rid of it. So when you multiply by the same radical, this root goes away. So the square root of 3 times the square root of 3 is the same as the square root of 9, which is just 3. So if I just multiply those two together, I get the square root of 3 all over 3. And here I can actually multiply by just the square root of 2. I could multiply by the 4 as well, but then I just end up simplifying more in the end, and that's just not worth my time. So that becomes 5 square root of 2 all over 4 times 2, because remember this root goes away, and we're left with 5 square root of 2 over 8. And taking that a step further, I can apply the same procedure to something with more than one root in the denominator. So the first step that I need to take is to multiply by the conjugate, which looks like this. So it looks the exact same except for this middle part here. And that is actually the same rule that we would use when we would FOIL something like this. Remember, it creates those two terms in the middle that cancel out. Here it does the same thing. It's still going to give me a positive and negative, but those two cancel in the middle. So all I really care about is eliminating these things. So let's distribute, multiply that out, and see what we get. So when I simplify this all out, I work it out, I distribute it here, I simplify it here, move some things around, and then I end up with negative 6 plus the square root of 6 all over 15. Something to note here. Although writing it like this, putting the radical and then the constant second is fine, it's very easy to accidentally extend this radical top here or mess it up. So we always put the radical at the very end. And then also we don't like to keep our negative in the denominator, so we move that up, and you can either negate the whole top, which you would actually need parentheses for, or distribute the negative, or the trick that I use is I just put the negative right in line with the fraction bar, so I know that the whole fraction is negative, but I don't have to worry about making the top negative or positive. So those are the tricks there. Great job, you nailed it, and that's going to do it for this video.